In rational expressions number 2, we're going to focus on the arithmetic of rational expressions, the adding, subtracting, multiplying, and dividing. We'll start with multiplying because it's usually the easiest one to deal with. And the thing about multiplying, if I have 15 over 28 times 14 over 9, multiplying two fractions, we just multiply straight across the numerator. So 15 times 14 over 28 times 9. And in order to simplify, we have to cancel common factors. That's why I didn't multiply this out at all. Instead, I want to look at 15 as being 3 times 5, 28 as 2 times 14, and 9 as 3 times 3. Then we have this fraction of 3 times 5 times 14 over 2 times 14 times 3 times 3. And to cancel common factors, we look for those factors that are the same in the numerator and the denominator, like that 14 and that 3. And what is left in the numerator is just 5, and in the denominator is 2 times 3, which is 6. Now, of course, you wouldn't need to show all that work. However, in order to simplify a multiplication problem, it's good to cancel common factors first before you multiply it out. So now when we expand that idea to rational expressions and we have these fractions that are a lot more complicated, the idea is still the same, and that is that we need to factor each a part of the fraction first. So when I have 2x squared plus x minus 6, I'm going to want to factor that into 2x and x. And the negative 6 I'll factor into 3 and 2. So plus 4 minus 3, that'll make the 1x in the middle that I need. In the denominator, x plus 5 and x minus 1. On the other side, when I have x cubed minus 3x squared plus 2x, the first thing I could take out is an x. I'll leave me with x squared minus 3x plus 2. Which can factor into x minus 2 and x minus 1. In the denominator, I'll take out a 2x and be left with 2x minus 3. Now, I factored all of them fairly quickly. If you need to, take the time, pause the video, and verify for yourself that those are all the correct factors. Now that both fractions, both rational expressions are factored completely, what we want to do is cancel those common factors that we see in the numerator and the denominator. And one that I see is this, 2x minus 3, the x, and the x minus 1. Otherwise, I don't see any other common factors in the numerator and the denominator. So what's left is x plus 2 and x minus 2 in the numerator, and x plus 5 and 2 in the denominator. We should finish that up by multiplying this all out. We'll end up with x squared minus 4 over 2x plus 10. And there is our simplified fraction. When we're dividing, that's the same as multiplying by the reciprocal. So we're still multiplying, even though it looks like division. So it's going to be important to factor all parts. In the first fraction, in the numerator, we have the difference of 2 cubes. So I'll take the cubed root of each piece, and then square together squared. So x squared, instead of subtracting, I'll add that x times the 2 is 2x, and then squaring the 2 leaves me with plus 4. In the denominator, x squared minus 4 is x plus 2 and x minus 2. For the second fraction, I'm going to want to multiply by the reciprocal. And by the reciprocal, I mean we're going to take the second fraction and flip it over. So the x cubed plus 8 is going to be in the numerator. When I factor x cubed plus 8, that's the sum of 2 cubes. So I take the cubed root of each piece, and then square, subtract this time instead of add, together the 2 and the x, and square that plus 2. In my denominator, I'm just left with x squared plus 2x plus 4. Now that it's all factored, we want to look for those factors that are the same in a numerator and denominator. So for instance, I have this x minus 2, this x plus 2, and x squared plus 2x plus 4 cancels with the x squared plus 2x plus 4 in the denominator. And the only thing I have left is this guy that's up in the numerator, and that will be our answer, x squared minus 2x plus 4. When it comes to adding and subtracting, we think about the basic rules for adding and subtracting fractions, and that is to get common denominators. That would mean my first fraction, I would have to multiply by 3 over 3. And in the second fraction, I would multiply by 5 over 5. That would give me a common denominator in both fractions of 15. It's just the numerator of the first fraction. We have 9 15ths, and then the second fraction is 10 15ths. Adding those two together, we have 19 15ths. And you're going to find that leaving your answer as an improper fraction is going to be most beneficial for you. So now when we extend that idea to rational expressions, the fundamental principle is still the same. I'm subtracting two fractions, so I need to get common denominators. Good way to do that is take this first fraction, multiply it by the denominator of the second fraction. So x over x. And in the second fraction, we'll multiply by x minus 1 over x minus 1. That will give me two fractions with the same denominator, x times x minus 1. The numerator of my first fraction is 2x, and in the second fraction, we have x minus 1. When I subtract my two fractions, we keep that common denominator and just subtract the numerator. So I'm going to subtract x minus 1. Notice I put that in parentheses because a common mistake is just to do 2x minus x, which will leave you with x, but then the rest of your numerator you leave as negative 1. Instead, we want to subtract negative 1 and leave it as plus 1. Then my denominator is x squared minus x, and we are finished. Sometimes these expressions get a lot more complicated, and when we want to create a common denominator, we need to create a common denominator between all of our fractions. So we need to take a closer look at all of them. And in particular, I need to look at the last one. The first two fractions, the x minus 1 and the x, those are already completely factored. However, x squared minus 1 is the difference of two squares. So that's x plus 1 and x minus 1. When we create our common factor, you're going to notice that I'll start to use this notation where I'll just create one long fraction because I'm going to add and subtract all the numerators together, but once I create my common denominator, that denominator is the same then for the rest of my work. In my common denominator, I need to have x minus 1 as one of my factors. I also need to have this x as one of my factors. And finally, I need to have x plus 1 and x minus 1 as factors in my denominators. So I need to include this x plus 1. However, the x minus 1 is already in there. That's important to note because now when I go back to my numerators for this 2, I need to compare what I have in my common denominator down here with what was already in the original fraction. Since 2 over x minus 1 already had the x minus 1 in it, what's missing is the x and the x plus 1. For the minus 1, it already had an x in the denominator. What was missing is the x minus 1 and the x plus 1. And for the x minus 5, it already had the x plus 1 and the x minus 1 in its denominator. What was missing was the x. Now I have an expression that we can simplify. It looks like a huge mess right now, which it is. However, we can simplify quite a bit. In the first part, let's take 2 times x and distribute it inside for 2x squared plus 2x. Then I will have negative 1 times x squared minus 1, and plus x squared minus 5x. A lot of us will be tempted to just leave that as our work, but we do need to include the denominator with our fraction. We can simplify things a little bit more, because I will take 2x squared here and subtract this x squared and add an x squared. So 2x squared minus x squared plus x squared, I would just leave it alone at 2x squared. Moving on to the x's, I've got plus 2x and minus 5x. That leaves me with minus 3x. And the last piece is doing negative 1 times negative 1, which is plus 1. We are almost finished. We do still need to check for common factors between the numerator and the denominator. So that's going to mean that we have to factor this numerator. And we factor that into 2x and x with a 1 and 1. To make a negative 3, I'll need minus 2x and minus 1x. And once it's factored, we do see that we have this common denominator, or this common factor that needs to be canceled of x minus 1. And so we can finish it up by just simplifying the denominator. And we'll have x squared plus x. For one last example here, what do we do when I'm adding a fraction to something that's not a fraction, to this 9? And the key is to look at the 9 as a fraction, as 9 over 1. Then when we create our common denominator, we're going to need x plus 1 and 1. So that would just be x plus 1. Meaning this 4 already has x plus 1 in its denominator, so we don't need to multiply it by anything. However, this 9 has a 1 in its denominator, and so we do need to multiply it by x plus 1. Now we just clean up the numerator. 9x plus 4 and 9 would make 13. It's not looking like we can factor that numerator anymore, so there's not going to be any factors that will cancel. And here is our final answer.